Voyager 1 just turned back and confirms what we all feared for nearly half a century. Voyager 1 has been racing outward at speeds no human creation has matched for so long. Now drifting in a realm where the sun's influence has all but vanished, and the galaxy's raw forces dominate unchecked. Built in the 1970s, with technology that seems almost primitive today, this resilient probe was expected to fall silent after mere years. Yet it has endured nearly 50 years, sending signals across distances that strain the limits of human engineering. And what it has begun transmitting in recent months is profoundly disturbing. Voyager 1 has encountered a region of interstellar space that defies every prediction, revealing conditions that suggest the void between stars is far more structured, far more energetic, and far more threatening than anyone dared imagine. Tonight, we are going to explore what Voyager 1 has just confirmed, why scientists are calling it a confirmation of our deepest fears, and how this distant machine is compelling us to confront the true hostility of the galaxy beyond our protective bubble. Voyager 1 is a spacecraft that has repeatedly defied its own expiration date. Conceived in an era of limited computing power, with data storage on magnetic tape and processors weaker than those in modern toys, NASA engineers never dreamed it would survive into the 2020s, let alone penetrate the interstellar medium and return data that upends contemporary astrophysics. Voyager 1 was propelled outward by a rare alignment of planets, borrowing momentum from Jupiter and Saturn to hurl itself beyond the known worlds, capturing images of volcanic eruptions on Io and intricate rings around Saturn that transformed our view of the outer solar system. But after its planetary encounters ended, Voyager 1 did not decelerate or go quiet. It accelerated into the unknown, evolving from a visitor to distant worlds into humanity's lone sentinel in the space between stars. For years, researchers debated the precise location where the solar system truly ends. The heliosphere, that immense cavity carved by the solar wind, was thought to present a relatively defined frontier against the interstellar medium. Simulations suggested a pronounced shift, with magnetic fields reorienting sharply and particle environments changing abruptly upon crossing the heliopause. Voyager 1 was anticipated to register unmistakable signs of this transition. Instead, something profoundly unsettling emerged. As Voyager 1 neared and then pierced the heliopause, it recorded persistent plasma waves and unexpectedly aligned magnetic fields, indications that the boundary was not a crisp divide, but a region of ongoing interaction and compression. Yet the latest signals reveal an even more alarming persistence. These disturbances have not faded with distance, but have intensified in unexpected ways, suggesting Voyager 1 has entered a vast, structured anomaly that alters everything we thought we knew about interstellar space. This is where Voyager 1 has confirmed its most feared discovery. Recent data from its plasma wave subsystem and magnetometer show a sustained elevation in magnetic field strength and plasma density that began years ago but has now stabilized at levels far higher than the surrounding medium. The probe appears to have plunged into an immense cloud of ancient interstellar material, possibly the ionized remnant of a long-extinct star or a dense local interstellar structure, where magnetic fields are amplified and plasma behaves in ways that trap and redirect high-energy particles. This directly challenges decades of models that portrayed interstellar space as relatively uniform and quiescent. Scientists must now confront a troubling truth. The galaxy is threaded with hidden regions of extreme turbulence and energy, regions that could render vast swaths of space inhospitable in ways our solar system's calm bubble has shielded us from understanding. What Voyager 1 has revealed carries implications that extend far beyond theoretical astrophysics. If interstellar space contains these extensive compressed zones where magnetic fields intensify and plasma densities rise dramatically, then galactic cosmic rays, The relentless high-energy particles from ancient supernovae may be focused and accelerated rather than diffused, penetrating deeper and with greater violence than anticipated. Voyager 1's measurements indicate that such regions act almost like lenses or barriers, modulating radiation in unpredictable patterns. This matters profoundly because these rays pose the greatest threat to life and machinery beyond protected environments. Voyager 1's findings imply that the galaxy is not a neutral void, but a landscape of hidden hazards, forcing a re-evaluation of how shielded planetary systems truly are and how rare, stable conditions for complex life might actually be. What has truly alarmed scientists is not merely that Voyager 1 entered interstellar space, but that its ongoing observations reveal a persistence of anomalous conditions no simulation had foreseen lasting this long or spanning such scales. Theoretical models depicted the local interstellar medium as recovering from solar influences relatively quickly, with fields and densities returning to baseline galactic averages. Yet Voyager 1's latest transmissions show the elevated magnetic intensity and plasma signatures enduring across billions of kilometers, as if the probe has been immersed in a single colossal structure rather than passing through transient waves. This stability and anomaly undermines the assumption of a predictable interstellar environment, compelling physicists to acknowledge that stellar remnants and galactic dynamics create persistent features capable of dominating local conditions for immense distances. One of the most evocative analogies now employed to convey Voyager 1's discovery is that of a vast cosmic cloud enveloping the probe. Rather than drifting through empty space, Voyager 1 seems to have entered a diffuse but enormous region where ancient plasma, heated and magnetized by forgotten stellar events, lingers and imposes its own order. The probe detects amplified fields that drape and compress, plasma waves that hum faintly but incessantly, and particle behaviors that suggest containment rather than free flow. This means our solar system is not simply moving through neutral medium, but brushing against or even partially immersed in these galactic relics. Voyager 1 is not traversing open space. It is probing the shadowed aftermath of cosmic violence that persists across eons. As Voyager 1 ventures deeper into this anomalous region, another ominous trend has solidified. Galactic cosmic rays, while modulated, show patterns of unexpected focusing, confirming that interstellar space hosts environments where radiation is not merely present, but concentrated. Inside the heliosphere, solar magnetic fields scatter and deflect much of this barrage. Beyond, in uniform conditions, diffusion was expected to dominate. Voyager 1's data now indicate that structured magnetic clouds can channel rays along field lines, creating corridors of heightened danger. This discovery carries grave weight. It suggests the galaxy is laced with zones where radiation threats are amplified, implying that safe havens for biology or exploration may be far more isolated than hoped. Perhaps the most astonishing aspect remains that Voyager 1 continues to reveal these truths at all. Equipped with instruments from another technological age, running on power that diminishes inexorably, with subsystems methodically deactivated to prolong its life, the spacecraft persists in delivering insights that reshape our cosmic perspective. Teams interpreting its faint signals today employ tools unimaginable at launch, yet they grapple with data from a machine older than most of them, a living link across generations that relentlessly exposes the same sobering reality. The space beyond our sun is not the serene emptiness we once envisioned. One of the most startling insights from Voyager 1's prolonged observations is that the local interstellar medium is not the smooth, featureless expanse predicted. Instead, it appears sculpted by external forces, with magnetic fields strengthened and plasma compressed in ways that suggest the sun's motion through the galaxy drags it into or alongside vast structures. Voyager 1's path has carried it into this enhanced region, where conditions remain altered not transiently, but over scales that dwarf the heliosphere itself. The medium is not passive. It is marked by the echoes of stellar histories, imposing boundaries and intensities that our models failed to anticipate. Another profoundly troubling revelation concerns the behavior of magnetic fields in this zone. Expectations held that interstellar fields would dominate independently, reorienting freely from solar influence. But Voyager 1 measures fields that remain unexpectedly strong and coherent, as if draped over immense distances by compressive forces. This persistence should not occur in open space, yet it does, forcing a reconsideration of how galactic magnetism organizes on large scales. Rather than decoupling cleanly, fields appear to interconnect and amplify across regions, creating environments where energy builds rather than dissipates. Voyager 1's instruments have further disclosed that interstellar space is dynamically alive at subtle levels. Plasma waves persist at low but detectable amplitudes, densities vary in structured patterns, and magnetic fluctuations reveal underlying turbulence. This contradicts the view of the space between stars as stagnant or uniform. Instead, Voyager 1 demonstrates that the galaxy pulses with residual motion from long-ago cataclysms, with ionized clouds retaining energy and organization that influence everything within their reach. The probe is not sampling emptiness. It is immersed in the preserved turbulence of cosmic evolution. Perhaps the most disquieting lesson from Voyager 1 is that its discoveries were never anticipated in this form. Each transmission from the anomalous region has compelled revisions to assumptions held confidently for generations. Models were refined and elegant, forecasts bold, yet the data prove more intricate and foreboding. Voyager 1 does not violate physics. It illuminates how partial our grasp has been, exposing a galaxy structured by hidden violence rather than serene equilibrium. One of the most intriguing specifics uncovered by Voyager 1 involves the faint but continuous plasma emissions. For years, its plasma wave subsystem has captured narrow-band oscillations, a subtle drone that maps density variations with exquisite precision. These are not sporadic but enduring, revealing that the medium harbors persistent activity driven by embedded energies. This suggested the interstellar environment carries signatures of ancient heating, leaving plasma in states that sustain waves across vast distances. Voyager 1 is flying through the lingering breath of stars that perished before our sun ignited. Another unsettling finding is the apparent scale and stability of the anomaly. On fine scales, turbulence reigns, fields twist, densities shift, waves propagate erratically. Yet on broader scales, the enhancement persists coherently, as if bounded by larger galactic forces. Voyager 1 reveals that chaos and persistence intertwine, with local disorder overlaying grand structure. This layered complexity defies simplified modeling, indicating that interstellar space organizes itself in hierarchies we are only beginning to discern. Perhaps the deepest irony in Voyager 1's saga is that it continues uncovering truths with tools never intended for this environment. Its sensors were calibrated for planetary magnetospheres and solar wind, not the subtle hum of interstellar plasma or the draped fields of galactic clouds. Yet decades on, Voyager 1 remains our sole direct observer of these phenomena, coaxing profound insights from aging hardware through ingenuity and patience. This underscores a fundamental truth of discovery. Breakthroughs often arise not from flawless design, but from endurance and openness to the universe's deviations from expectation. As Voyager 1 presses onward, distance has become an unrelenting adversary. Signals arrive as whispers against cosmic static, each bit of data delayed by nearly a full day, each command a gamble requiring extraordinary foresight. This remoteness highlights a stark reality few missions encounter. Beyond certain thresholds, human oversight fades, and the probe navigates autonomously through conditions no real-time adjustment can address. The discovery is quiet yet immense. Interstellar exploration demands surrender to isolation, where persistence alone bridges the gulf. One of the most insidious challenges Voyager 1 has illuminated is not particles or fields, but the pervasive noise of the cosmos. Space teems with electromagnetic clutter from distant sources and energetic events, making the probe's transmissions increasingly fragile. As it delves deeper into structured regions, distinguishing signal from this galactic cacophony grows ever harder. Voyager 1 reveals that the universe is not a silent recipient of messages, but a crowded, indifferent expanse where only the most resolute voices endure. After nearly 50 years, Voyager 1 stands not merely as a traveler, but as a weathered witness operating at the edge of viability. Power ebbs gradually. Instruments yield one by one to conservation, yet even diminished, it yields vital science. This longevity itself informs us. Survival in harsh realms teaches about degradation, resilience, and the quiet strength of simplicity over complexity. Perhaps the most transformative insight from Voyager 1 is that entering interstellar space marked not a conclusion, but an immersion into something vaster and more intricate. Scientists once viewed it as a remote threshold, a final frontier. Voyager 1 proves it a domain with its own architecture, scarred by ancient forces and governed by rules that challenge our solar-centric views. The probe did not escape into void. It infiltrated a realm shaped by galactic history on scales that dwarf our imagination. When the full scope of Voyager 1's observations crystallizes, the discovery transcends science and becomes profoundly humbling. This aging artifact has confirmed that interstellar space harbors persistent, structured anomalies where magnetic compression and plasma enhancement create conditions far more energetic and hazardous than foreseen. The heliosphere is not merely a bubble, but a fragile refuge. And the galaxy beyond is not tranquil, but marked by relics of violence that linger and dominate. What renders this confirmation so feared is not contradiction of physical laws, but exposure of our vulnerability. Researchers assumed a relatively benign interstellar medium. Voyager 1 proves otherwise. Magnetic amplifications endure. Plasma structures persist. Radiation modulates in threatening ways. And all this emerges from a probe of 1970s vintage, powered by fading sources, bridging inconceivable distances with fragile signals. Consider this deeply. Humanity's farthest emissary is revealing that the space awaiting us is not the open, welcoming expanse we envisioned, but a domain of hidden intensities and ancient scars, demanding greater caution, better shielding, and deeper humility for any future beyond our sun's domain. Voyager 1 did not merely venture farther. It compelled us to mature in our understanding of the cosmos, warning that the true frontier is unforgiving and demands respect. If you seek to remain informed on revelations of this magnitude, ensure you stay connected because the profound truths emerge not from spectacle, but from faint data traversing impossible voids. Offer your reflections below, because these findings touch on questions fundamental to our species' destiny among the stars. And know that even now, Voyager 1 presses onward into the depths, steadfastly confirming the fears we harbored about the galaxy's true nature at its most remote edges.